The earth as we know is a home of life and opportunity that spins and spins and spins to give us 2 moments during a day. The daytime, where the bright sun brings life and joy to public outings and outdoor activities. And nighttime, where the stars beam specks of light as half of the world sleeps, waiting for the next day to come about. And at that stage, that was all that time was to us. It was such a basic concept. And nowadays, we use time in more ways than our predecessors could have even imagined. Now, let's wonder, how did our improved accuracy of time telling revolutionize the modern way of living? Although the hunters and gatherers of the Ice Age were the first to develop a system to track the moon to tell time using sticks, the first true use of calculating time was not until the Babylonians and Egyptians used calendars to schedule public events and other outdoor activities amongst them. They are based on 3 things: a solar day, a lunar month, and a solar year. However, this would strongly vary from place to place, as people of different latitudes did not experience the same amount of daylight nor effect of the seasons, making this system extremely inaccurate for people outside of a given area. The Egyptians discovered something that helped cushion other similar beliefs regarding the year length, which included the calendar of the Sumerians in the Tigris-Euphrates River Valley, which had 12 months each with 30 days. All the Egyptians did was look up at the stars. See, when you look up at the stars, you might see a couple or none, while others might see a beautiful cluster of stars. Either way, we know that there are practically an infinite number of them. Does one ever stand out to you? Well, to them, one did. The star Sirius. They realized how every time the star Sirius would rise up to its zenith, the Nile would flood. Due to this, they based a calendar off of it. This not only helped improve the timing with trade, but also improved how future plans would be planned with nearby groups. This finding was revolutionary, as it caused the Egyptians to make a new system of telling time. This system was created by the idea of temporal hours, a system of 12 periods of darkness, which are equivalent to about 2 hours in modern time. The issue with this system was that it could drastically change depending on the seasons, since the summers give longer days while the winters give longer nights. Although inaccuracies still existed, they were still able to have fairly precise times for gatherings and events. They did this by inventing 2 things, the sundial and the water clock. The sundial based time off the sun's shadow, which was inaccurate when the seasons changed. The water clock was based on when the water levels would rise and fall, with engravings on each side saying when an hour would pass. Problems occurred when evaporation rates would rise or fall, making time changes pretty frequent. However, these systems popularized, being adopted by the Greeks and the Romans for more than 2,500 years. Now, although we could compare the Aztec and Mayan civil and solar calendars versus their sacred calendars, which helped both of them with keeping an agricultural schedule and planning religious events, they never really evolved into the modern way until the Spanish came into the picture. The last thing we'll mention is the introduction of the Julian calendar in 46 BC by Julius Caesar, which is still used in certain Orthodox churches today. It not only introduced the leap year, making a year 365.25 days, but it was also the most precise form of the calendar at that time. This helped improve Europe's system of time to plan for goods being exchanged and different events to occur. During the beginning of this period, sundials were used all the time. Not only was it used to identify the midday, but it was also able to be carried in pockets or hung on people's doors. Although these did advance to be able to counteract the seasonal changes, mechanical clocks began to take over. This began in the 14th century and it popularized over time around the cities of Europe. This not only allowed the churches to schedule prayer times and other events, but allowed for schools to also be run on a schedule. These clocks were also used in some of the first bell towers. The problem with this mechanism was that the amount of time it took the escapement to go back and forth solely depended on the pull into it, which was hard to keep standard. The spring-powered clocks were also a useful invention in the 1500s by Peter Henlein, allowing for the creation of smaller clocks and even helped introduce the idea for watches. Due to people now being able to have the same clocks in their houses, everyone was able to keep time at the most accurate rate so far. Scientists during this time also realized the fault of the Julian calendar. This was due to its slight inaccuracies, which made the calendar added up to them being 14 days behind. This made people ask for a more accurate one. Pope Gregory made a calendar which was not only the most accurate of them all, but in turn gave different dates for different equinoxes. This popularized so much in Europe, likely due to the Pope's power, that it began to popularize through the world and is the principal calendar used to this day. This not only helped everyone stay on the same date, but with the help of later ideas like the time zone, it truly revolutionized the way different communities stay together, greatly standardizing record keeping and helped organize seasonal activities of the church. Later in the 1600s, Christian Huygens invented the first pendulum clock, removing the reliance of a physical force and instead allowing it to swing naturally. It was so accurate at one point that it would be only off by 10 seconds a day. His creation led to so many other innovations to the clock. This can be seen in the new materials being used for the escapement to reduce friction and enhancing the clock's accuracy by 1 second in 1761, or the short clock made in 1921 that used two pendulums, one to push the principal, one to keep its motion consistent and accurate. These clocks were heavily used in astronomical observatories and helped improve the accuracy of trade amongst different regions as it became the national standard time. Now, scientists in the late 1920s thought of even newer ways to enhance our accuracy of time. They began to work with the special property of piezoelectricity of quartz, causing quartz to vibrate when it is electrocuted. These scientists realized that these vibrations occurred at a steady rate, which would solve all the errors of the pendulums and short clocks from before. These clocks were also small and cheap, being used by most of the population and improving manners to schedules and everyday activities. Microwaves and watches are still some of the appliances that continue to use them to this day. New innovations began to come out later with atomic clocks, which were so perfect. They were based on the vibrations of the atoms of the element cesium, which was also used to define the second. The atomic clock is the most precise form of time telling that we have today, and it's used a lot in different forms of communication agencies and for travel due to its new role as the standard time. Nowadays, the majority of clocks we see are digital, whether that is the calendar on your tablet, the time on your alarm clock, or the boards to check flight times. Everything has become digitalized despite the concurrent existence of newer models of the quartz and atomic clocks. Not only that, but with the help of the modernized time zones and transportation stations, it has become easier to organize events, trade, and help with traveling. The profound accuracy of measuring time has helped revolutionize how our daily lives transformed. From the planning of religious rituals of the Aztecs to the calculation of departures and arrivals of thousands upon thousands of airplanes at a time, the measurement of time has only become more valuable as time went on. Just imagine how you would wake up tomorrow and all your clocks went out.